Welcome. Today let's understand about fuel temperature sensor. The sensor name itself is suggesting we are measuring fuel temperature here. In this video, we will learn what is fuel temperature sensor, how does it work, what are the types of temperature sensor. Give me few seconds, I'll bring my whiteboard for detailed explanation of this sensor.
A few inches later.
First, let's understand this block diagram. Here we have fuel tank and this is fuel temperature sensor which is connected to ECU. This is a fuel filter to remove impurities from the fuel, and this is a 3-cylinder engine with spark plug and fuel injectors. Fuel injectors and spark plugs are controlled by ECU. When it comes to the location of fuel temperature sensor, it can be either found in the fuel tank along with the fuel pump, or it can be on the fuel lines or along with the fuel filter. When it comes to the temperature sensor, it consists of an element called thermistor. Thermistor is an electronic component whose internal resistance depends upon temperature. That is, as the temperature varies, the resistance output of a thermistor also varies. And depending upon the relation with the temperature, we have two types of thermistor. One is PTC and another one is NTC. PTC is positive temperature coefficient thermistor. That is, temperature and the resistance are directly proportional to each other. That means as the temperature increases, the resistance also increases and vice versa. When it comes to NTC, it is negative temperature coefficient thermistor. That is, the temperature and the resistance are inversely proportional to each other. As the temperature increases, the resistance decreases and vice versa. Here you can see I have taken temperature in the x-axis and resistance in the y-axis. Here, as the temperature is increasing, the resistance is decreasing. For this example, I have taken 10K thermistor. That is, maximum resistance will be 10K. Here, if you can observe, at minus 40 degrees we are getting maximum resistance output, that is 10K, and as the temperature is increasing, at 0 degrees we have 5K or 6K, at 80 degrees we have 2.5K. That is, as temperature keeps on increasing, the resistance keeps on decreasing. This thermistor will be connected to a voltage divider circuit and we will get an voltage output. Now, if you can observe this graph, this is voltage output of the thermistor versus the resistance of the thermistor. Here, the resistance and voltage are directly proportional to each other. This relation we get from the Ohm's law, that is V is equal to IR. Here you might get a doubt that what is the correlation between this graph and this graph. That is, how do we know at this particular resistance we are getting this particular temperature? If we are getting 10K resistance, it is 40 degrees, or 5K resistance, it is 0 degrees. This data will be supplied to us by the sensor manufacturer. That is, it will be provided in the data sheet of this sensor. It will be in both tabular form and graphical form. And this temperature sensor will be calibrated from the factory. Now let's come to the part where we will learn why do we need fuel temperature sensor. That is, what is the need to measure the temperature of fuel. As we know, we need AFR ratio for the ignition timing and spark timing, right? And we also know AFR depends on many parameters, and among them few parameters are air density and air temperature. This we learned in earlier videos. Now let's understand the AFR is also dependent on fuel temperature and fuel density. Fuel, that is petrol or diesel, both are volatile in nature. That is, they can easily exist in the vapor form at normal temperature. Density of the fuel is directly dependent on the temperature. If the density of the fuel is less, it can easily mix with the oxygen, thus producing the effective combustion. If the fuel is more dense, then it will need more time to mix with the air molecules, thus delaying the combustion by few milliseconds. If we can get the fuel temperature values, we can optimize the AFR ratios for different densities of fuel. Now let's understand what happens if the fuel temperature sensor is faulty, or the wiring is damaged, or if the ECU is getting intermittent signals. First thing is MIL, that is malfunction indication lamp, will come on dashboard. That indicates a fault code is generated by the ECU. That is, ECU has detected some issue or fault in this system. and by reading the fault code we will get more information on the fault. Next one is lower fuel economy. Since the AFR ratio is not optimized, ECU might overcompensate and use more fuel, that is run in a rich condition, thus it might consume more fuel. Next one is higher emissions. If the AFR ratio is not accurate, engine might run in lean condition or rich condition. Depending on that, engine might produce more black smoke, it might produce more carbon monoxide or nitrogen oxide which are harmful in nature. We can even observe rough idling. Then last one is misfire and knocking. If the ECU is not able to calculate ignition timing and spark timing accurately, engine might misfire or it might lead to a condition called knocking. I'll explain you this concept in detail in future videos. Now let's say if you want to understand more about this sensor, you can use tools such as multimeter, oscilloscope or OBD2 scanners. If you found this video to be informative or you learned something, please do like, subscribe to this channel for the future videos. I will meet you in the next video. Bye bye.